Okay, so in the last unit, we did area of composite figures where they took like 3 or 4 figures, put them together. Like one of them was like a triangle with a half circle on it. One of them was like multiple rectangles together. Some of them were a triangle sitting on top of a square. And we found the area of those shapes and added them together. Well, they also do that with composite figures for 3D shapes. So even a 3-dimensional object can be considered composite. And the volume of a composite object can be found by either adding or subtracting the volume of each shape. So when we were doing the area ones, we typically found the area of each of the shapes, added them together. We also did some where we subtracted, and that was like when it said, what is the area of just the shaded region? We found the area of the whole thing, we found the area of the shaded, and subtracted them. So with 3D composite figures, we're going to be finding the volume of each of those shapes and adding them together, or if there's like a cutout, we'll subtract it. So it says brainstorm various 3D dimensional objects that are composed of more than one shape. First thing that I thought of was a cone with a sphere on top of it for ice cream. An ice cream cone is a 3D shape composed of a cone and a sphere. What else could be a 3D shape that you might know in real life that's like made up of multiple 3D shapes? Oh, come on. I also picture like Stonehenge. You all know what Stonehenge is? So like a stone, like a 3D dimensional stone, and then like another one sitting on top of it is what I kind of pictured. Somebody else in the other class said a house, like the roof, and then the house. I think they were probably looking because there's a house down here at the bottom. I was looking at this one and I thought, some like really trendy chairs are like this, where they're like a block, like a hollow block, and then a hollow block that you sit on. Have you ever seen one of those at like those fancy furniture stores? Yeah. I don't know. I was just thinking about that. All right, but anyways, we'll go ahead and get started here. So it says decompose each object into different figures, then find the volume of each figure. So let's refresh volume real quick. So remember our volume formula is big B times H. What does this big B stand for? Naomi? Base area. So area of the base. This H stands for the height of the whole figure. And then remember, we did 2 types of prisms. We had rectangular prisms where the base was a rectangle. We had triangular prisms where the base was a triangle. So remember, if it's a rectangle, then I would do area is base times height. If it's a triangle, I did area is 1/2 base times height. All right, so when I look at number 1 here, it says decompose it into different figures. So what you're going to do is you get to take a choice here. So some people may take a line and they may cut it this way. And other people might take a line and cut it this way. Does it matter? No, it does not matter. All right, so we're going to take a vote. Do we want to cut it across? Or do we want to cut it down? So raise your hand if you want to cut it across like this. It's still just going to be straight down, though. It just looks diagonal because it's a 3D shape. All right, raise your hand if you want to go down. All right, so that's where we're going. All right, so we're going to go like this. So everybody draw a line like this to cut it. And that's going to leave me with 2 3D rectangular prisms. So there's one of them. We'll call that one shape 1. And then here's another one, and we'll call this one shape 2. All right, so let's start with shape 1. So area, the formula for volume is area of the base times the height of the figure. So let's look at the base here. This is a rectangular prism, so it has a rectangle base. So I need to first find the area of this base. Well, I know that this is 8, but what is this right here? 12. And I know that because we talked about how the bases are parallel, so they're the same. So if this is 12, so is this, and so is this. So I'm going to do area of the base, so 8 times 12. What's the height of this yellow one? How tall is this yellow one? 6. Right here is where I see that for height of the whole prism. All right, so I'm going to take my calculator and do 8 times 6 times 12, or 8 times 12 times 6. And I find that the volume of shape 1, the yellow one, is 576, and that's millimeters cubed. All right, and now we're going to move on to the pink one. So here's my base. There are no numbers on my base down there, nothing. What the heck? What am I going to use to find for area of the base? Do I have any ideas, Naomi? All right, this 8. So this 8 is 8 here, which means 8 is here, which means 8 is here. But what about this side over here? How am I going to figure out what that is? Ava? So like here, if this and this should be the same because they're all part of that same base. So if this is 8, so is this. All right, so once again, it's area of the base times the height of the figure. So the base is an 8 by 8. So area of the base is 8 times 8. And what's the height of this pink figure? 16. Right here tells me how tall it is 16. So I'll use my calculator. 8 times 8 times 16. And I get 1,024, and that's millimeters cubed because it's volume. So the composite volume for both of those together, so to get this number, I'm going to add together our two volumes. So the 576 plus the 1024. So the composite volume is 1,600 millimeters cubed. All right, so looking at number 2 here, it says describe how the same process would apply to the object below. Caden, what shapes do you see in this shape right here, this house? Do you see any 3D shapes in this house? Yeah, box. Okay, but what do we call a box? This is called a... Tell me, Lindsay. Okay, so you see a triangular prism where? On the roof, the top. So this is a triangular prism. And Caden, did you figure out what the bottom is called? A rectangular, because it's a rectangular base prism. So this house is made up of 2. Can anybody tell me the difference between a triangular prism and a rectangular prism and like finding the volume? Maddie? Yeah, with a triangular prism, remember area of our base is 1/2 base times height. So this one you use the 1/2 and this one you don't. All right, we're going to flip it over and we're going to look at number 3 together. And then I'm going to let you try some on your own. All right, so number 3. There are multiple ways that you can cut this. I don't care. I would always say try to cut the least amount. So like some people in my other classes, they were like, I want to cut here and here. Why make it 3 shapes if you don't have to? So it says, use your understanding of composite volume to solve the problems below, but sure to label. All right, so I'm going to cut this one right here. I'm just going to cut it right there. And I've got 2 rectangular prisms again. Got this yellow one and this pink one. All right, so let's first start by finding the volume of this yellow one. All right, so I'm looking at this base down here. So here's my base. So it's telling me that this is 4, this whole thing's 18, this is 4, this side's 4. All right, so area of this base down here is 4 times something. What's this side? Right here, what's this side going to be? I know, but what's the number? 4, and because I know from right here that this is 4, that I can bring that down and say that this is 4. So area of my base is 4 times 4. So that's 4 and 4 right there. What's the height of the figure? 18. I see it right there, 18. So I'm going to use my calculator. 4 times 4 times 18. And I get 288. And we'll just label at the end. All right, then I'm going to go for this pink one. All right, so I don't see any numbers down here on the bottom for this pink one. A lot of people want to say, oh, this is 12 right off the bat. Is it 12 or is it not? I might be asking a trick question. I don't know. It is 12? Okay, good. Because some people earlier were like, no, it's 8 because there's an arrow here. But I'm like, that arrow is pointing to this, not to this. So this is 12 right here. How tall is the base? How tall is this base right here? So remember, if I don't, this is 6 right here. This is 6. But what about this bottom, this flat bottom? How long is this piece? 4. And I get that from right here. Because remember, the bases are parallel, so they're the same. So if this is 4, so is this. So now I can do area of the base. So 12 times 4, because it's base times height. And how tall is this prism? How tall is this one? 6, because this piece is 6, how tall it is. So 12 times 4 times 6, I also get 288. So 288 plus 288 is 576, and that's centimeters cubed. All right, I'm going to let you all try number 4 on your own. Everybody give it a whirl. So if you're struggling, I'll give you a hint that I probably would have cut it here. And then there's your 2 shapes. You've got this big one and this little small one. Must have not right anymore. All right, let's look at this pink one. All right, so here's my base down here. How long is the base? How long is it right here? From here to here is 19. How long is just from here to here? 13. And I know that because up here is 13, so I bring that down. What about this way? How tall is the base? Right here. What is this length? 6. Because right here is 6, so I know that this is 6. So area of the base, so 6 times 13. How tall is the pink one? 15. So 6 times 13 times 15. and I get 1170. All right, for this one's a little tricky. How long is this base right here? I figure it out. How long is that blue part? 6. Because look again, ready? Please look up here. From here to here is 19. From here to here is 13. So 19 minus 13 is 6. So then your area of your base is 6 times 6. How tall is the yellow shape? 5. That rectangular prism has a height of 5. So 6 times 6 times 5 is 180. So then 1170 plus 180 is 1350, and that's inches cubed. Anybody get that? Something was said? All right, I'm going to give you all a hint for the next one. There is only one way to cut it, and that's completely across. But here's the thing. This shape here is the same as this shape here. So if you find one of them, then you know both of them. Okay? All right, so go take a minute and let's do this one. Y'all are really quiet. So once again, you don't have to work out both of these yellows. Once you know this one's the exact same because they're the same numbers. So if you get this as a number, then this is the same. All right, so let's start with this yellow one here. So the base down here is a 3 by 2, and it's a rectangular prism. So area of the base, 3 times 2 times the height, which is 4. So I get 24 for this one, which means this one is also 24. For this pink one, I don't know the base down here. So like, I know that this is 10, but what about this here? Like, what's this side? Anybody know? 2, because if this is 2, we can assume this is 2. So 10 times 2. And what's the height of this? This is where people messed up earlier too. What is the height of the pink one? 3. Yes, Ava, because look right here, everybody. From here to here is 7. All the way. From here to here is 4. So we assume that the height of the pink one is 7 minus 4, which is 3. Good job. All right, so 10 times 2 times 3 is 60. So then I'm going to do 60 plus 24 plus 24, and I get 108 feet cubed. All right, let's take a peek at number 6. So it says a wooden toy is shaped and decorated like a house. How many cubic centimeters is a wooden toy? I want to point this out right here. On your test, it does not always say what is the volume of the shape. It might say, what is the cubic inches? What is the cubic feet? What is the cubic centimeters? This word right here means volume. Because area, it would say square feet, square inches, square centimeters. But with cubic, they're talking about volume. What 2 shapes did we say we saw here? All right, Ava. A rectangular prism and a triangular prism. Oh, yeah. All right, here we go. All right, let's do a refresh together on the triangular prism. So remember the triangular prism. A triangle is 1/2 base times height. So this is going to be 1/2. What's the base of this triangle here? What's the bottom base? 8. How tall is this triangle? 5. It tells me right here that the height of the triangle is 5. And then remember, it's volume equals area of the base times the height. How tall is this triangular prism? How tall is the whole thing? 15. Because remember, this is sitting on its side, so it's 15 centimeters tall. So I'm going to do 1/2. So 0.5 times 8 times 5 times 15. And I get 300. All right, I want you all to find the volume of the yellow one. Find the volume of the yellow one. All right, what'd you all get for the volume of that rectangular prism? Area of the base, so 9 times 7 times the height of the figure 15, and we got 945. Add those together, 300 plus 945. I got 1,245, and that is centimeters cubed. Woo! All right, last one, and we're not gonna have homework tonight. Yay. All right, so number 7, a prism has a cube-shaped hole. So I think of this, I mean, it's a cube washer. You know, like a washer, like when or like a bolt, like how you like screw down over top the screw. I think of that. I don't know what else this would be. So that's kind of the way I picture it in my head. Huh? All right, the cube. So this inside cube here, what they're talking about. The cube measure is 6 by 6 by 6. So they're talking about this right here is 6 by 6 by 6. So what is the volume of the prism? So this is a hole, which means they're cutting it out. So that means that I'm going to find the volume of the hole. I'm also going to find the volume of this shape and then do what with them? Subtract them because they're cutting that out. So they're trying to take out this middle part. So I'm going to find the volume of this cutout. It's a cube, so it's just 6 times 6 times 6, which is 216. This pink shape, though, is 18 by 18 by 6. So area of the base is 18 times 18. The height of this is 6. So 18 times 18 times 6 is 1,944. And I just used my calculator. Like, I'm not doing anything myself. But since this part is a cutout, they punched a hole through it, they said, I'm going to take out that 216. So I'm going to subtract them this time. Because they're taking, it's like a hole punch in the paper. They're taking it out. So the 1,944 minus 216 is 1,728, and that's centimeters cubed.